Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 61 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Nano. I'm going to need you to pour yourself a nice big mug of iced coffee. That would be strong black coffee poured over ice, no sugar, no sweetener, none needed. I'm also going to need you to get out your Jetson Nano gear. And as you're getting your gear out, as always, I am going to give a shout out to you guys who are helping me out over at Patreon. It is your encouragement and your support that keeps this great content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to learn today. What I'm going to do is show you my solution to the homework assignment that I gave you in lesson number 60. And that homework assignment was to add speech capability to the image recognition capability on the Jetson Nano. And so what the assignment was to speak what was put in front of the camera. But there were a few quality requirements that I put on the assignment. The first one was that you can't freeze the camera where you're doing the speaking. So you couldn't be going along with smooth video and then freeze the video and then speak and then come back and resume the video. The video has to continue to roll smoothly. That's pretty easy to do. I think you see how to do that is with threading. The second requirement, though, was to not be annoying. What do I mean by not being annoying? You wouldn't want to do something like this. Pill bottle, pill bottle, pill bottle, pill bottle. Don't sit and repeat yourself. You want to say it one time. Pill bottle. Okay, now this is kind of interesting because if you think the speaking is different than the viewing, right? That in our frame where we're showing the video, if there's a pill bottle there, you want it to always have a label on the video saying pill bottle. Okay, but what you hear, you only want to hear it one time. So we got to deal with the auditory data a little bit different than the visual data. Okay, that's a little bit of a tricky thing there to figure out how to do that. All right, so one thing is don't be annoying. What is another way that you could be annoying? If you put this up here and you said pill bottle, toothbrush, hairbrush, pill bottle, coffee cup, right? Don't speak unless you're fairly confident in what you have to say. And so you don't want to just say everything that it thinks it might see. You only want to say the things that it is fairly confident of. Okay, now I will be honest with you. This turned out to be a lot harder than what I thought it was going to be. Initially, what I thought about is, okay, just use a thread, and by using that thread, then you could be speaking and showing video at the same time. But what I found is when I just jumped in and started coding without completely thinking through it, I ended up in this situation where it could get stuck in the speaking thread and it could just keep saying the same thing over and over, whether there was anything in front of the camera or not. Or it also could get stuck over in the recognition where it would kind of lock up and either wouldn't be recognizing or wouldn't be changing what it was recognizing. And so I found a lot of different ways to get this where it would kind of lock up into one state or the other. And that's when I said, okay, I've got to practice what I preach, and I've got to do what I tell you always to do. You got to think like an engineer. You've got to map it out on paper, and you got to get it working on paper before you jump in and start coding. You've got to have a strategy. Okay, so before we jump in and start coding, I want to describe to you the strategy. All right, first of all, you've got to think of it in terms of one big wheel. Okay, one major wheel. What that major wheel is, your major loop is grabbing a frame and showing a frame. Grabbing a frame and showing a frame. You've got to keep doing that because you don't want the video to freeze up or be glitchy. So you've got to do that all the time. Now within that, there is one of two things that you can be doing, but you only want to be doing one at a time. One is you might want to be speaking. Pill bottle. The other is you might want to be recognizing. Okay, but you don't want to be recognizing in the middle of speaking, or you don't want to be speaking in the middle of recognizing, because there's certain variables that both of those functions need, and you don't want those two functions to be trying to grab and change the variables at the same time. And so what I did was I used a flag, and basically I had a digital flag that I called speak. And speak is either true or speak is false. If speak is true, then in the speech thread, I would speak. If speak is false, then I don't speak and I recognize. So you could really kind of think of it, you could use two flags like speak and recognize, and while speak is true, recognize is false, and while recognize is true, speak is false. But really you can just do it with one flag, and I called that flag speak. So while speak is true, it speaks. While recognize is true, it doesn't, or while speak is false, it doesn't speak. Okay, it doesn't speak, and it recognizes. So it is always grabbing a frame and showing a frame, but then it is either speaking or it is recognizing, but one of either of those, not both of them at the same time. Okay, enough of this describing the strategy. Let's jump in and let's start coding. So I will move out of your way. We will open up the most excellent Visual Studio Code, and then we will come over here and start a new folder, or start a new program. I believe we have been working in the folder NVIDIA. It looks like we got up to Deep Learning 10. And so I'm going to come here. I'm going to click on it. I'm going to add a new file. And that new file will be Deep Learning 11.py. Okay. And that looks good. We have a fresh new program. We also need to go over to the most excellent www.toptechboy.com. Okay, let's go there. And we're going to grab that program that allows us to, we're going to grab that program that just sort of fires the camera up, just so that we don't have to develop things completely from scratch. And so I think I can search on something like Nano Camera. And we should be able to find it pretty easily. It's not that one. It's not that one. Starting the Raspberry Pi camera or a web camera on the Jetson Nano. That looks like what we want. And this will give us a head start on developing the code. So we will come down here and click on the two little icons, right mouse click copy. We will come back to Visual Studio Code and we will paste that in. Okay, couple of things I want to do. I want to come down here and put in my move window. So I will say cv2.move window, and I'm going to put that. What do I want to move? I want to move nano cam, and where do I want to move it? I want to move it to 0, 0. So we start out nice and neat. And then we will be using the webcam today because it's just a little easier to point the webcam, so we will be doing that. And hopefully you guys have realized that on Jetpack 4.3, which we are on now, you just can't put in a camera number, you have to put in the path. And so we need to put in quotes the /dev/ for me it is video 1. If you have more than one webcam, you might be video 2 or video 3 or something like that, but I am video 1, so that looks good. And then I think we're going to go ahead and run this just to make sure that we have something, that is working here before we go any further. I like to kind of check the code as we go. Okay, that's good. That's good. All right, now as we do this, what I'm going to do, the way I'm going to do it is I'm going to kind of add logical blocks. I'm not going to try to sit and just write the whole code all at once. So the first kind of logical function that I want to add to this is I want to add the image recognition capability. Then when that's working, we will come back and we will add the talking capability. So up here at the top, we need to load a few libraries. We need to load the Jetson.inference. Okay, we need to import the Jetson.utility tils, okay? And then we also are going to need NumPy, so we are going to import NumPy as NP. That looks good. And then because we're going to be doing our frame rate, we need to import time. Okay, that looks pretty good. I also think that I'm going to come here and I'm going to use width and height as my parameters because that's kind of what we use later on. So I'm just going to say width, and I'm going to set this a little bigger. I'm going to set it to 1280, and then I'm going to set height, HEIGHT. I'm going to set that to 720. Make sure you set this to parameters that are allowed by your webcam. If you set this to something your webcam doesn't recognize, it can cause problems. I'm using the Logitech, and these values it seems to like. All right, so I've set those. All right, then I am going to need to create my camera here. That looks good. And then I think after creating my camera, I can I'm going to go ahead and set the size. All right, so after I create the camera, I want to go ahead and set the size because we've got to make sure when we pass parameters to that inference engine that we pass it the actual width and height of the camera. So we want to explicitly set that. So I will do a cam.set, and that is going to be cv2.cap underscore prop underscore frame underscore width. And there you can see my autocomplete is working, my IntelliSense is working, and I'm going to set it to width. And then I think the easiest thing will be to copy that and paste it, and then we are going to set the height. We will set the height, and then here we will set the height. Okay, so that should give us a bigger window. Okay, and we have loaded our libraries, and so that is good. And so let's think of what else we are going to need to do. Okay, we're going to have to set up a couple of variables here for the identification. And one of the things, I'm going to go ahead and set up this flag, which is speak. Okay, and I'm going to go ahead and say speak is equal to true. So I'll just set that, get that out of the way. And then what I'm going to do is I'm going to go ahead and set up an item. All right, and that item is going to be the first thing that I'm going to want to say. The first thing that I'm going to want to say is a welcome when we turn the thing on, and that is going to be welcome to my Identify. Are you ready to rumble? Okay, are you ready to rumble? That looks good. Put a question mark. All right. And now a couple of other things that, remember, we're only going to speak if we're confident of what we're speaking. And so the first time through, we need to give it a value. We'll set that variable up. Confidence is 0 because we haven't found anything yet. And then also, remember, and I'm just setting the variables up. Remember how we don't want it to say pill bottle, pill bottle, pill bottle. We got to keep track of not just the item that we're looking at now, but what the item was last time through the loop. And so we need to have another variable, which is item old. Okay, so, and that's just going to start out as nothing. But what you got to think about is, as we go through the loop, item is going to become the item that it's looking at, and item old is going to be the item last time through. So we have two variables, item old and item. And for this first time, I'm just borrowing the variable item to put my welcome in. I hope that makes sense. I do hope that makes sense. Okay, so I think that we've got a lot of good variables set up there. So now let's come down and actually get ready to do our, there's a couple more. There are a couple more variables I think that we should go ahead and set up. Let's see. No, we can do that. We can do that later. So we are going to come down, and after we set the camera up, let's go ahead and let's set up our inference engine. And so we will call that net is equal to Jetson.inference, Jetson.inference.image.net, okay? And then what we are going to be looking at is the Google Net. That will be the model that we're using. So we now have our inference engine set up. We are going to want to label, we're still going to want to label the video frame what it's seeing, and so we need to go ahead and set up a font, and so I'm going to set up the font to be equal to CV2 dot font Hershey font Hershey CV2 font Hershey Simplex will be what I will use. Okay, that looks like a good font. And then also we are going to be doing, remember we're going to be doing the frames per second on the window. And so I need to go ahead and I need to grab a time mark. So I will say time mark is equal to time.time, like that. And then also we're going to be doing a low pass filter. So I need to initialize that. The frames per second FPS filter is going to be equal to 0, just to set that up, is equal to 0. That looks very good. That looks very good. So I think I've got a lot of my variables and stuff set up. I think I'm ready to come in and really start recognizing. And again, initially I'm just recognizing. I'm not going to be recognizing and speaking. I am just going to be recognizing. Okay, so let's get that going. So we read the frame. Now, one thing that we have to remember is the Jetson inference engine wants RGBA, and it wants the numbers to be 32-bit floating numbers. What we got to remember is CV2, when it grabs a frame, it grabs a NumPy array. It grabs it as blue, green, red, and 8-bit integers. So we've got to convert that into what the Jetson inference image is looking for. So what we need to do is we need to create a new image out of frame, and that new image, IMG, is going to be equal to CV2.CVT color. So we're going to CV2, we're going to convert color, right? And then what are we going to convert? We're going to convert frame. And how are we going to do the conversion? CV2 dot color. Do you remember that? CV2 dot color underscore BGR to RGBA. Okay, so we're taking that NumPy array that's in red, green, blue, and we're turning it into blue, green, red, A. And A is like an alpha channel, which I think is like transparency. So we will put it as it wants it, and then we've got to do the conversion to 32-bit float. So we will go as type, and what do we want? NP float 32. So it was 8-bit integer. It's now going to be a 32-bit float. So I think that looks really, really good. And now the final thing is this is still a NumPy array, and we've got to put it down on the CUDA. We've got to create a CUDA array. So we will now convert. We will say IMG is equal to Jetson.utils, and then what do we want to do? CUDA from NumPy. And what do we want to do that on IMG? So this will take the NumPy IMG and turn it into a CUDA array. And so that looks really, really good. And now what do we need to do? We need to go ahead and do our classification. So we can say class ID is going to be equal to class ID is going to, or class ID, we are doing a net.classify that returns two parameters. The first is the ID number of what it sees, and the second is how confident it is. So confidence, okay? And that is going to be equal to net.classify, and that's going to be IMG, comma, width, comma, height. All right, so what does this mean? This means we are going to do an image classification on our IMG, which is now a CUDA array in the right format, and we're telling it what its width is and what its height is, and we set that up here as width and height, and then we set the camera to that width and height, so everything should line up. Now that will return a number like item 23. We got to figure out what the name of item 23 is. And so what we will need to do is we will need to say that the item, this is going to be a string, this is going to be a name, is equal to net.get class description of what? Of class ID. So that'll take that number and put a word, put a good label on it, okay? And so that looks good. Now, the command that you all know that, or wait a minute, now what I will need to do is, let's go ahead and calculate, because we want to display our frames per second, let's go ahead and calculate our frames per second here. And so what I can see is dt, or the change in time between the last loop and this loop is going to be, what time is it now? Time minus what was the time last time was time mark, right? And we set that initially at the very top. Okay, dt is equal to time.time minus time mark. That looks good. Let's go ahead and grab time mark for the next time through. And so now time mark for the next time through is going to be equal to time.time, like that. Now, what is our frames per second? Frames per second is 1 over dt. And so frames per second is equal to 1 divided by dt. And now we're going to put a low pass filter on the frames per second so it's not jumping all over the place. We're going to smooth it out by saying FPS filter is equal to 0.95 times FPS filter, and then plus 0.05 times our new frames per second, and this smooths it out. Look at my lesson on low pass filters if you don't understand this, but now I have a good low pass filter on there. And now what I want to do is I want to display all that information on the window. Okay, I want to display all that information on the window, so I'm going to do my most dreaded command of cv2.putText. Okay, and then where do I want to put it? I want to put it on frame. Why frame? Because that IMG was just to do the recognition. We're still going to display our old frame. Okay, that was just to do the analysis. We're still going to display the old frame. And then what am I going to put? Well, I'm going to make a string out of the rounded value of frames per second filter. And then what do I want to do? I want to round that to 1 decimal point. So I take the frames per second filter, I round it to 1 decimal place, and then I turn it into a string. So that's one thing I want. Then I also want to put a label on that. So I will add to that string. This is just a label, frames per second FPS. Okay. And now I also want to add to it the item that I found, right? I want to put that item that I found. And then also I want to put the confidence, okay? And so then to item, I will add another string of round of confidence, and I will round confidence to 2 places because it's like 23%, 57%, 0.23, 0.57, like that. Okay. I think that's good. That is everything I need for the label. Now I got to tell it where to put the label. Well, I'm going to put it 0 over, it'll be in the corner, and 30 down, and that way it will be completely in the frame. So 0 over, 30 down should be a good position for it. And now I need to put my font. I need to put my font in, okay, which I set up already, and then a text size of 1. And now I got to give it the color. Let's make it red, which would be 0, 0, 255. All right. And now I need to, I think, do I put like the text weight next? I think I have one more number, which is going to be text weight. And I will go ahead and make the text weight 2. And with a little luck, with a little luck, that will work. Oh man, I am afraid to run this thing. How many horrible mistakes have I made? That was a lot of coding there, right? That was a lot of coding. Also, be aware that the first time we run this, it might take a little time to get the Jetson Inference engine up and running. Sometimes the first time you run it, it takes a minute or two. So don't panic. As long as it doesn't crash, we will be okay. All right, it is running in here, and it looks like it's going to start doing some stuff. Okay, it's loading the cafe model. No errors, so far so good. That's kind of encouraging, but we could still have errors down in this main loop, particularly that put text. That put text is a very hard command for me to get right. We will enjoy sipping a little coffee here while it's doing this. The good news is, while it's doing this, after the next time we run it, it won't take this long. It will not take this long the next time we run it. Okay, it looks like we have some signs of life here. Okay, ooh, and we got an error in line 40. FPS filter is not defined. I thought we defined that. That was on our frames per second filter. Did I misspell it when I put it up here? Or did I not just not put it up there? Oh, frames per second. Oops, sorry. Hopefully you guys caught that. All right, let's try it again. This time it should run quicker. I thought it should run quicker. Maybe because it crashed. Maybe because it's crashed, it's still kind of starting over. Still is not happy. Okay, now, oh, it says I gave it too many. It does not like that put text. I told you that put text kills me every time. That put text kills me every time. So let's come up here and let's look at that put text. Did you guys find it? Tell me if you saw my mistake there. It says takes at most string takes 3 arguments, and I gave it 6. So it looks like that string really looks good. Maybe it was this other one. Oh, okay. I think, do you guys see what I did? I closed the round, but I didn't close the string, so I needed one more there. Okay, and then let's make sure that there's not an extra one somewhere. Yes, there is an extra one out here. All right, this I feel pretty good about. Let's try it again. I feel pretty good about it this time. That was not too bad of a mistake, a parenthesis error. That could happen to anyone, right? That could happen to anyone. And it's not about writing perfect code. It's about being able to troubleshoot and find your mistakes. And so we are at that long step of the cafe model. And okay, boom, shazam. Look at that. Frames per second, 9.7 pill bottle. That looks good. Let's just try something else. Let's see if we come up here and put that coffee mug. That looks good. Okay, now the one thing I don't like is I don't like how I didn't put a space after the item and before the confidence. I really needed a space in there. It ran that together, and so I had item, and then I went from item right into confidence. And so I'm going to add just a blank string in there, and then I'm going to add the other string. Do you see how I did that? I just put a blank space in there. So that should work at this point. And I think we are ready now to move to the hard part, and that is the speaking part. Okay, we've got to put the speaking part in. And so let's start with the easy part. And the easy part is, I think that you can see that we will need a what? We are going to need a thread. So I'm going to build the thread before I start the camera here. So I'm going to go ahead and build the thread right here. All right. And so on building that thread, what we will need to do is we will need to create a function. And so I'm going to define a function. I'm just going to say item because we're teaching it to talk. Not going to pass it any parameters. Okay. But what you got to see is there's two things that everybody needs to know. I mean, the function needs to know, the thread needs to know, the main program needs to know. And those two things that are needed to be known are speak. Is speak true or is speak false? So we need to make that global here. So I will say global variable speak, because otherwise the functions don't share variables unless you make them global variables. So speak is going to be global, okay, and also what we need to say global is going to be the item, right? And so not global, global and item need to be the speak and item need to be the global variables. All right. Now, what you got to see is with a thread, if I start a thread, it'll just go up and then leave it and end. I need this thread to keep running, so I need to put a while loop in here, just while true. Okay, while true. So once you start this thread, it's going to keep running. All right. But I don't want it to say pill bottle, pill bottle, pill bottle, pill bottle. So what I need to do is I need to put an if statement in here. If speak equal true, then I'm going to do the speaking. If speak is not true, I'm going to sit there with my mouth shut and I'm not going to just keep babbling. Okay. So if speak is equal to true, what am I going to do? Well, output is going to be equal to, remember this from last lesson, GTTS. I decided to use the Google text-to-speech as opposed to the Easy Speak just because the quality is better. So GTTS, and then the text is going to be equal to item. That is a global variable, so it should know it, not test. Text is equal to item. Okay. It's a global variable. It will know it. Language, L-A-N-G, is going to be equal to E-N for English. And then slow is going to be equal to false. So that's saying I don't want it to speak slowly. So that will create my output. Now I need to save my output with output.save. And that is going to be saved in output.mp3. Now I didn't put a path, which means it's going to put it in my default folder, which is for me my PyPro folder. If you're configured differently and you're not sure where this is going, you can put the complete path in front of the output.mp3. But mine is going to go right into my PyPro folder, which is just fine. And then I need to do the os.system. And then how do I speak this? I speak it with mpg123 space output.mp3. Now I need to make sure that I imported that OS library, which I have not imported that yet. And so let's see. Let's go ahead and import OS. And then also we are going to need to import, remember that, a couple of other things. We also need to import the talking, the Google text-to-speech, and import that, or we're going to do that a little different. This time we're going to say from GTTS, we are going to import GTTS. Make sure of case the first one, GTTS, is all lowercase. The second one, it's lowercase g, uppercase T, T, and S. Does that make sense? Make sure you get that right, or you are going to be in a world of problems. And then also we need to import threading because we are going to be doing some threading. Okay, now we've got our libraries. Let's come down here. And so what we did was we said that if speak is true, then what we want to do is we want to create the sound, we want to save the sound, and then we want to play the sound. Now, this is key. It is at this point that we are going to set speak equal false. Why is that? Because this thread keeps running on its own. And somewhere you have to tell it to stop speaking. When would you tell it to stop speaking? After you set it. Pill bottle. Okay, now, even though the pill bottle is still there, you don't want to say pill bottle, pill bottle, pill bottle. You say it one time, and then you set speak to false, and then it can just loop through there without saying anything until it's told speak again. And that will be the main loop. When it's done recognizing, then it will set speak to true, and then it will say whatever the next item is. Okay, I hope that makes sense. All right, so that should be good. So let's come back over here, and now let's go ahead and set it up as a thread. So we're going to say x is equal to threading.thread. Okay, and then our target is equal to, say, item. Okay, and then we want to do the daemon equal true, and that just kind of takes this thread, and if the main program stops, it'll stop the thread. So you would hate to not do this and have a bunch of threads running after you stopped your program. So this ensures that they die cleanly. Okay, and then let's go ahead and start that thread. Okay, so what's it going to do? It's going to start it's going to create the thread, it's going to start the thread, and then initially, what did we say? We said speak is true and item is welcome to my identify. So with speak being true, it will get into this loop, it will give the welcome, speak will be false, and then as it continues to spin, it won't say anything, right? So if the models are loading or the recognition or that stuff is going on somewhere else in the program, it's not going to keep giving the welcome over and over. It's going to give it once, and then it's going to shut up, and that is what we want. Okay, so that is good. But now, remember what else we said? We said if we're speaking, we are speaking and not recognizing. If we are recognizing and not speaking. So down here, what we have to see is we have to kind of think about, we don't want to be recognizing while we're speaking. We want to do one thing at a time with regards to this. So we will go ahead, we're always going to be grabbing the frame and converting it, having it ready to go. All right, but we only want to recognize if we are not speaking. So this would be if speak equal false. Okay, if speak equal false, that means we are not speaking. That means we can what? We can recognize. So then I need to tab this over. And so I'm done speaking. Speaking is finished with those variables. Now I can recognize. So I do the recognition. All right. But remember something else? The other thing is we don't want to say things. We don't want to say things if we are not confident in what we are saying. And so we want to say if confidence is greater than or equal to 0.5. That means we're not going to say anything unless, that's less than or equal to. That should have been greater than or equal to. Greater than or equal to 0.5. We don't want to say something unless we're sure of what we say. So if we're greater than 50% sure, we will speak. So if confidence is greater than or equal to 50% or 0.5, what will we do? Well, we will figure out what our item is. Item is equal to get class description of what? Class ID. Why am I doing that? I'm so silly. I already got it. I just got to tab it over and put it inside the if statement. So this, we're only going to do this if we are 50% confident or more. So if we're 50% confident or more, we'll go ahead and we'll get our item name. And, all right, now do I want to say speak equal true? Well, what would be the problem with that? If I just said right now speak equal true, I would have pill bottle, pill bottle, pill bottle, pill bottle. I only want to speak if the item is not equal to the item old. So I only want to speak if pill bottle has not already been spoken. And the first time it sees it, it will say pill bottle, and then the next time it'll recognize, well, wait a minute, pill bottle is still pill bottle, so I'll be quiet. So only when the item name changes, only when the item name changes will we speak. So if item is not equal to item old, then what do we do? Now, finally, we say speak is equal to true. So let's think about this. We only identify if we are not talking. If we are not talking, we can identify. Then we do the identification, and then only if we are greater than 50% confident in what we're saying do we move to the next step, which is to figure out what the item is. And then only if it's a different item than what it was last time do we actually speak. And then speak is true. Well, at this point, it would come up here, and it would say the item, and then it would be quiet. It would set speak to false, and then it won't speak again until all these things are true, until the confidence is greater than 50% and it's a different item, and then we would speak again. Okay, well, we also have to take some action here, and you've got to get this lined up with the if statement of confidence greater than 50%. Well, what do we do if the confidence is less than 0.5? What do we do then? Well, then we haven't found anything, so we just say the item is equal to nothing because it hasn't found anything. So we have to explicitly tell it something, because imagine if I had here, it would say pill bottle, and it would say it once, but then when I took it away, it would still be displaying pill bottle on the window. So I have to tell it, okay, if you're not 50% sure, we're just going to put it on nothing so that you're not displaying the last item that it saw, if that makes sense. All right, now the final thing we have to do is we've got to get ready for the next loop. And so lined up with those if statements, those two if statements, we need to get ready for the next loop, which is item old equal item. So we're ready to get out of this loop, but we got to say, hey, remember what item old is, remember what the item was last time. So hopefully this makes sense. Oh man, what is the chance that we didn't make a million mistakes in all of this? But I think this is ready to, go. So let's try this. Right mouse click, run Python file in terminal. The tension builds. I'm so excited. We're at that tense spot. Here we go.
Welcome to my identify. Are you ready to rumble?
Yes! Okay, so we must have had some item old is not defined was the problem. Did I misspell it? Item old is equal to item. Did I not put item old up here with an initial value? Ah, look at that. An old typo, item old. Did you guys catch that? Okay, let's see. I also was kind of nervous how that thing just hung there for a long time, so I think I probably have another error in here, but we'll get to the bottom of it. If there's one thing I hope you guys learn from me, it's troubleshooting. Okay, it's loading the cafe model. Here we go.
Welcome to my identify. Are you ready to rumble?
Okay, so boom. Okay, why am I happy? It gave the greeting one time. It recognized the teapot and it said teapot one time. Okay, so let's try something else here. Let's try this.
Remote.
Okay, it's a remote control. All right.
Remote control, remote. Beaker.
Beaker, did you hear that? It did say beaker. Okay, let's try this.
Coffee mug.
Coffee mug, very good. Coffee mug. Now this one is hard because it's small, but we'll see if it can do it.
Screw.
Screw. Okay, it saw that. This one it has a little trouble with, but let's see if it...
Mouse, computer, mouse.
Mouse, computer, mouse. Boom! Guys, do you see this?
Mouse, computer, mouse.
Okay, let's try this.
Computer, keyboard, keypad.
Computer, keyboard, and keypad.
Spacebar.
Spacebar! Boom!
Computer, keyboard, keypad.
Okay, now this...
Shower curtain.
Okay, and shower curtain is okay because it's seeing the green screen back here and it's interpreting it as shower curtain. Now, I do find the shower curtain thing a little bit annoying, and so if I were going to do a little bit more on this, I would just tell it to never say shower curtain because I know that that's the background. But let's try this one again. Beaker. Okay. Guys, this is really incredible.
Teapot.
Teapot. Okay, guys, I hope you are having as much fun with this as I am. How are you guys? And do you see how this is really working now? It never locks up. It always speaks. It speaks one time. It doesn't repeat itself. It's kind of like it's just absolutely bulletproof the way it's working. But that didn't happen the first time. That happened after I carefully went in and kind of mapped things out. How much success did you guys have when you tried to do it? Did you run into some of the same problems that I ran into? Were you able to come up with a solution? Because this is like real world problems where typically in the past we always kind of had linear flow to our programs, but now we've got to kind of worry about timing where we have different things going on at the same time and we don't want to have the thing get locked up or get lost. And so a lot of times in the real world I had to deal with problems like this, and so I kind of think this is really a cool real world problem. Okay, 61 lessons in the book here. We can just put a wrap on this thing, and I hope you guys are having as much fun taking these lessons as I am having making the lessons. And I'm really particularly excited about these last few lessons where we're becoming more interactive with the world around us, that we can get signals from the GPIO pins, we can send signals to the GPIO pins, we can control servos, we got information coming in from cameras, and now we have taught the Nano to say what it sees. Okay, guys, if you like this, give me a thumbs up. Think about subscribing to the channel. When you do, make sure that you ring that bell so you get notifications. Share this on your social media. Show your Facebook friends what kind of stuff you are working on. If you guys want to connect with me on Twitter, I'm Paul J. McWhorter on Twitter. I also just got on Gab. On Gab, I am Paul McWhorter. On Facebook, I am Paul and Anna McWhorter, Paul space and Anna space McWhorter. And if you want to hook up with me on Facebook, send on over a friend request. Okay, guys, I have really had a lot of fun. Hope you have enjoyed this. And this is Paul McWhorter with TopTechBoy.com. I will talk to you guys later.